So previously we've looked at how we sketch graphs, the key bits of information that we need, and what we need to do in order to build up an accurate sketch of any function. What we're going to look at in this case, in this video, is imagine I give you the sketch of a function. You're going to be able to take that sketch, look at the key bits of information in it, and be able to sketch the derivative of that function for me and tell me what it looks like. That's going to be the aim in this video here. Now, one thing I do want you to remember is that while it is possible to sketch any derivative, the derivative changes the function itself. Now, what I mean by that is that the degree of the function, the highest degree of the function, is always one less than the original function itself. So for example, if we originally have a quadratic, when we take the derivative of that, the highest power is going to be a linear power, i.e. just an x. So if I had the quadratic y equals x squared plus 2, the derivative of that, dy by dx, equals 2x. So I've gone from a quadratic with the highest power of 2 to a linear function. If I had a cubic, so let's imagine I had y equals x cubed plus x squared minus 1, and I took the derivative of that, dy by dx, in this case I'd get 3x squared plus 2x. What that's done is taken what was a cubic and turned it into a quadratic. So a cubic goes down to that. And it's the same if I had a quartic, so a power of 4. So let's imagine y equals x to the power of 4 plus 2x. If I take the derivative of that, so dy by dx, what I end up getting is 4x cubed plus 2. So my highest power has gone from being a quartic to the power of 4 to a cubic to the power of 3. So that's one thing we have to bear in mind when we're looking to sketch the derivative, because that's one way the function changes. So if I've got a quadratic to a linear, my original function might look something like that, but my derivative looks like that. It's a straight line. Now what we have to be able to do is look at the graph of the original function, look at the key bits of information presented there, and be able to translate this across and sketch it into the graph of the derivative. Now one thing we have to remember is that the derivative tells us about the curve of the function, which also then leads us into the nature of the function and the nature of the curve itself. When we had a negative derivative, what that meant was our rate of change was negative, so we had a downward slope. So a slope of our graph would look something like that. When we had a positive derivative, that meant our rate of change was up the way, i.e. it was a positive rate of change, so something like acceleration. It would be an upward curve like that. It would be sloping up the way. So we have to remember that and bear that in mind when we are sketching the graph of our derivative, because that is going to come into play itself. Now when we were sketching the derivative, if we just took our steps from before, what we'd be able to do is the exact same three sets of steps. So calculate the turning points, or the zeros of the function, calculate the behaviour of the derivative either side of this, so it tells us the slope either side, maximum, minimum, and then use that information to sketch the graph. So think back to when we did that for functions. We could do that with the derivative. However, if we are given the sketch of the original function, we're able to look at that and translate that information over to what the sketch in the graph of the derivative should look like. When we are sketching the derivative using the original graph, we have to match up and make sure we've got a couple of key bits of information. The first one, we have to match up the turning points of the function to the x-axis. So if we take the original function, we have the turning points. Remember, the rate of change of the derivative is equal to 0 at that point. So any turning point matches up to a 0 or an x-axis intercept or a root of the derivative. The second one is we have to look at the actual values of the original function. Now, if it's a positive slope, sloping up the way, that means our derivative is positive. Any point where that happens, the graph of the derivative is above the x-axis. Similarly, if we have a negative slope, so we get a negative value for the derivative, anytime where that occurs, the graph is below the x-axis, so it's got a negative value. We can build this information all together and it helps us to sketch the graph. Let me show you. Imagine I take a quadratic. So I'm going to take a quadratic. Now we know it sketches into a linear function, something that looks like that. The key things you have to look at, you look at the turning points first, and then you look at the slope. So I can imagine I've got a turning point here. I know that that's going to translate to a 0 on the derivative. So that is where my line is going to cut the x-axis. I then look at the information either side of this. Now, to the left of it on the quadratic, it's a negative slope. It's coming down the way. So my slope is negative here, which means that my derivative is also negative. So to the left of this root of my derivative, I'm going to have negative values, i.e. my derivative sketch is going to be below the x-axis. If I look to the right of the quadratic, my slope is positive in this case, so my derivative is positive. It takes positive values, which means that when I translate this over to the sketch of my linear derivative, it's above the x-axis, so it's positive values. If I've got a negative derivative, a negative slope, I've got negative values here. If I've got a positive derivative and a positive slope, I get positive values from a derivative. Imagine we had a cubic. Well, again, the first thing we have to look at is the turning points. So for this cubic, I've got two turning points, two stationary points there and there. Now, they translate to any roots that are of my function. So these translate to two roots, one that's located here and one that's located here. So I know that's where it's going to cut the x-axis in my derivative. What I then have to do is look at the values and how they change either side of these stationary points. Now, to the left of this stationary point, it slopes up the way. The cubic's coming up, which means I've got a positive value here. What that means is my value of my derivative in that section is also positive. So it's above the x-axis. To the right of this, so between my two roots here, it's a downward slope, so it's going to be negative. So I'm going to have a negative value, so my derivative is going to be below the x-axis. But I've got to come back up for this other root given by the stationary point. So what I have to do is when I sketch it, make sure I put a turning point in about halfway and come back up to the other root. Then I look at the other side of the original function. It's an upward slope, so it's going to be positive values from a derivative. So it's positive values, i.e. it's above the x-axis there. So we can look at the slope of our original function and use this to translate the information over into the sketch of our derivative. Let's have a look at a couple of examples of this. So my first one, imagine I want to sketch the derivative of the following function. So I've got this function here. First thing we need to do is identify what kind of function it is. Well, this one here, it's a quadratic. Just by looking at it, I can tell it's a quadratic function there. Now I've got a stationary point on my quadratic at 1, -3. Remember, the stationary point means the derivative is 0, so that translates over to my root. So I know I'm going to cut the x-axis here at 1. If I look to the left of it here, I've got a negative slope. So my curve is coming down the way towards it. What that means is my derivative is going to be negative here, so I'm going to have a straight line and it's going to be below the x-axis. Above this point, it's an upward slope, so it's going to be a positive slope for my function, which means my derivative is positive. So here, the graph of my derivative is going to be above the x-axis because it's going to be a positive graph. We then have to make sure we match on our axis labels, so our x and our y-axis. And this is how our graph would translate over and look. There's our roots, given by the stationary points. Slope tells me if it's going up on this side. Slope here coming down tells me it's down below the x-axis on this side. Let's take it a bit further and look at higher powers now. So imagine I've got a cubic here. Cuts the y-axis at 7, which also happens to be the turning point. It's got a lower turning point at 4, -2. Now, first thing you look at is the turning points. That tells me where my roots are. I've got a root on the y-axis at 7, so I know I'm going to cut here. I'm going to cut through the origin at this point. I also know I've got a root at 4, -2 because that's where my turning point is. So my root is going to be there at x equal to 4. Now looking at this, I could tell it's a cubic, which means that my derivative graph is going to be a quadratic. Now it's just a case of looking at the values and the slope in each section here. So you can divvy it off, if you like, into 3 sections here. Left of the 7, so left of the root here on the y-axis, to the right of the root here at 4, and in between the two roots. Now, to the left here, it's an upward slope. Derivative is going to be positive because it's an upward slope, which means that my graph of my derivative is going to be above the x-axis. If we then look at this bit here, so imagine we're at the 4, -2, we know above here, it's an upward slope again. So it's going to be up this way, which means my derivative is going to be positive. So the graph's going to go up this way on that side of the 4. Now, if we look between the 2 points, so between these 2 stationary points, I've got a downward slope on my graph. That means my derivative is going to be negative, so my derivative graph is going to be down here below the x-axis, and it's going to curve back up there like that. So my quadratic, which is for the graph of the derivative, is going to look something along the lines here. It's going to have a root at 0, a root at 4, turning point here, and slope up and down like that. We have to bear these key bits of information in mind when we're sketching the graph of the derivative. We can look at the original graph and read off the key bits of information. We read off the roots, which are given by the turning points. We then look at the behaviour of the original graph either side of these. Positive slope means I've got a positive derivative, so the values are above the x-axis. Negative slope, or a downward slope, means I've got negative values of my derivative, so it's below the x-axis. Bear that in mind when you're sketching.